remember, when we graph quadratic equations or we try to solve them, we're looking for the solutions. And when we set our quadratic equation equal to 0, our solutions occur where the parabola hits the x-axis. So for example, if I just sketch a coordinate plane, my solutions when I graph my parabola are going to be where it hits our x-axis. Now, that works. We know we have two solutions, but what happens if we have a parabola that maybe hits right on the x-axis? Then there would only be one solution. Or maybe we have a parabola that doesn't hit the x-axis at all. What does that mean? Well, that would mean that there's no real solutions, no real number solutions. So we can find out how many solutions a quadratic equation has by using our discriminant. And the discriminant is the part under our radical sign. So our discriminant is b squared minus 4ac. And here's why the discriminant is important. If we have a quadratic equation written in standard form, set equal to 0, if you figure out the discriminant, b squared minus 4ac, and it's positive, then you have two solutions. If you get a 0, then it has one solution. And if it's negative, then it has no real solutions. Not that it doesn't have solutions, it's just not real numbers. So the discriminant tells us how many solutions a quadratic is going to have, how many times it's going to hit the x-axis. So let's look at an example. It says find the value of the discriminant and use the value to tell if the equation has two solutions, one solution, or no real solutions. So keeping in mind, we want things of the form ax squared plus bx plus c equal to 0, which these are. Okay, so I'm going to go ahead and go keep, change, and make that into plus and negative 2. And then I'm going to just focus on the discriminant. B squared minus 4 times a times c. Plug that in here. What is my b? Well, it's negative 2. Please put negative 2 in parentheses when you go to solve this. I still have people going negative 2 squared and your calculator's telling you it's a negative 4. It's not. Negative 2 squared means negative 2 times negative 2, which should be a positive 4. So that's why you always see me write it in parentheses. Minus 4 times my a. Well, what's my a? It's my coefficient of x squared, which is just 1, times c. c is a constant being added on, which is 4. So you just type this into your calculator and you get an answer of negative 12. Great. What does that mean? Use the value to tell if the solution has tell if the equation has two solutions, one solution, or no real solutions. If it's negative, then it has no real solutions. So we know that this, if we were to graph this, that the parabola would not hit the x-axis. Okay, so it has no real solutions. Let's look at this next one. Okay, same thing. I'm going to go keep, change, and make that into a plus and negative 1. And I'm going to use our discriminant. B squared minus 4 times a times c. And we just want to figure out how many solutions does this quadratic equation have. So we have b, which is 5, squared, minus 4 times a, which is negative 3, times c, which is a negative 1. Type that into your calculator. 5 squared is 25. 4 times negative 3 is a negative 12. Times negative 1 would be a positive 12. So we end up with 25 minus 12, which is 13. What does 13 mean? What does it mean when you get a discriminant answer of 13? It's positive, two solutions. So it's going to hit our x-axis in two places. So our last one here, keep, change, keep, change, using our discriminant. Our b is a negative 10 squared minus 4 times my a, which is a negative 1, times my c, which is a negative 25. When you evaluate that, you get an answer of 0. So what does 0 mean? 0, 1 solution. It's going to hit the x-axis right at the vertex. Okay, so the discriminant tells us how many solutions we're looking for. Let's look at another example. It says use the related equation to find the number of x-intercepts of the graph of the function. Okay, when we're talking about x-intercepts, we're talking about solutions. We're talking about where it hits the x-axis. To do that, you just have to set this equal to 0. Okay, it's equal to y. So if they want x-intercepts though, y has to be 0. So do the same thing. Use your discriminant, b squared minus 4ac. The number of x-intercepts will be the number of solutions. So for the first one here, 6 squared minus 4 times 1 times 3. That equals 24. That means we have 2 solutions. I'll show you on a graph in a second too what that means. Okay. How about this one? Set it equal to 0. We're going to have 6 squared minus 4 times 1 times my c, which is 10. And that equals negative 4. Negative discriminant means no real solutions. Last one here, if we set it equal to 0, using our discriminant, we get 6 squared again minus 4 times 1 times 9. And that equals 0. So we know there's one solution. Now this one said here, use the related equation to find the number of x-intercepts of the graph of the function. X-intercepts, when it's set equal to 0, are the solutions. So let's see what these pictures look like, or these graphs look like. So sketch a graph of the intercepts in the last example to check the number of x-intercepts. What is true if c is greater than 9? Alright, so what we're going to do is we are going to take these 3 equations and we're going to graph them. And I'm going to kind of cheat in here. My first equation was x squared, so x raised to the second, plus 6 times x plus 3. Now, before I click the graph button, remember we anticipate that there's going to be 2 solutions. So when I hit, oops, and there it's gone. Let me type that in again, sorry. Oops. X to the second plus 6 times x plus 3. Okay. When I hit graph it, look it, we do get our 2 solutions. Okay. Our leading coefficient is positive. We expect it to open up. And you could go through negative b times divided by 2a and figure out what the vertex is. But just to kind of see the graph, notice it hits in both places. Now, our next one was x squared plus 6 times x plus 10. And we had a solution of, when it said how many real solutions, or how many x-intercepts, we said there are none. So let's see what that means here. Yep, sure enough, here's our parabola. It's still opening up, but notice it never is going to hit the x-axis. It's going to continue on in both directions, but never hit the x-axis. Nothing wrong with that, it just doesn't have real solutions, because our solutions occur on the x-axis. The very last one was x squared plus 6x plus 9. So when I graph that, notice it's hitting right on the x-axis, and we anticipated there would be one solution. So this is what the graphs of those 3 look like. Now the last question, I'm not going to go back here because I don't want it to erase this, but the last question said, what happens as c gets greater than 9? Well, in this one here, remember this is where c is 3. This one up here, c is 10, and then this right here is when c is 9. So, what do you anticipate if it was c was equal to 5? I would anticipate that it's going to have 2 solutions. It's going to fall somewhere in here. So let's see. Excuse me. Yep, there it is. Okay, what if c was, let's say 8? Again, 2 solutions, but notice it's getting closer and closer to this right here, because remember this one represented when c was 9. What if c was 12? What would you think is going to happen? This is when it was 3, this is when it was 5, this is when it was 8, this is 9, this is 10. I'm kind of thinking 12 is going to be up here. is. Okay, so as C is going to become bigger than 9, that means we no longer have real solutions. As long as when C equals 9, so when this number here is 9, we have we have one solution. But as soon as it hits 10, 11, 12, sorry again about that, we're not going to have any real solutions. Okay, so if you're comparing these, notice as this number changes, all they're doing is they're sliding up.